Hello and welcome to Cannon County High School Algebra 2. Today is Monday, April 13th. I hope all of you had a wonderful Easter. Today we're going to talk about the sine, cosine, and tangent of special angles. This is a continuation of what we talked about last week because we didn't quite finish last week. So let's go a little further with sine, cosine, and tangent of special angles. So Mr. Lyon, you're going to have to sit over... No, Mr. Lyon, you're not allowed to take off the mask until the quarantine is over. We've talked about this. So just be patient. It'll happen. Okay, you stay over there. Let's talk about sine, cosine, and tangent of special angles. Last time, we took a long time figuring out the cosine and sine of all kinds of special angles on the unit circle. We figured out that the x-coordinate is the cosine and the y-coordinate is the sine of all of these special angles on the unit circle. And we figured out that in quadrant 1, they're both positive. In quadrant 2, the cosine is negative and the sine is positive. Down here in quadrant 3, they're both negative. And in quadrant 4, the cosine is positive and the sine is negative. And we talked a good deal about cosine and sine, but you're thinking, well, Mr. File, it says on the title of the video that we're going to talk about tangent also. So let's do that. Let's talk about tangent. A few videos ago, we talked about SOHCAHTOA. And that's just an easy way for you to remember that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So you know tangent is opposite over adjacent. Let's see if we can figure out the tangent of a 45-degree angle based on what we now know from what we figured out last time. So let's draw a 45-degree angle. A 45-degree angle, just like that. Theta is 45 degrees. Now you know from last time that the cosine is the square root of 2 over 2 and the sine is the square root of 2 over 2. So I'm just going to put those right here. Square root of 2 over 2, square root of 2 over 2. Now you know that the opposite over adjacent is equal to tangent. If I were to actually draw the triangle that goes with that, you know that the y-coordinate is this distance from there to there, square root of 2 over 2. And you know that the x-coordinate is from there to there. That's the square root of 2 over 2. So the tangent of 45 is just going to be the opposite side, the square root of 2 divided by 2, divided by the adjacent side, the square root of 2 divided by 2. And what do you get when you take something divided by itself? You get 1. And so the tangent of 45 degrees is 1. And that's one of the reasons why we need to learn these special angles, is because you can quickly and easily figure out sine, cosine, and tangent of them. And one place where that comes into play a lot is on the ACT test. The ACT loves problems where you can't really use your calculator to figure them out. They need to be in simplest radical form, but you should be able to figure them out quickly and easily. Okay? So now that we know that, let's try a few of them. Let's try that. Let's find the tangent of 30 degrees, okay? Now, you don't have to draw this whole thing every time. Really, as long as you know just the first quadrant, you can figure out the second, third, and fourth quadrants just by knowing what signs there are in those quadrants. So remember back when we were doing 30, 60, 90, and 45, 90 triangles, we used a little cheat sheet to help us with that. I've made up another one kind of with just a quarter of the unit circle. You don't need to know the whole unit circle. You just need to know the square root of 3 over 2, a half, and the square root of 2 over 2. As long as you can kind of recreate that, then you can figure out anything all the way around the whole circle. So let's try the tangent of 30 degrees. Well, one thing that we just learned is that it's opposite over adjacent. Well, since it's opposite over adjacent, that means that the tangent of any angle is really another formula that you can use for that, is that it's really just the sine divided by the cosine. Because on the unit circle, what happens when you take the tangent of 30 degrees? Well, the opposite side would be 1/2. The adjacent side would be the square root of 3 over 2. So that means you're going to take 1/2 divided by the square root of 3 over 2. And now it just becomes really an Algebra 1 type problem. You know that when you divide two fractions, that's really like multiplying by the reciprocal. So that's like 1/2 times, well, what's the reciprocal of the square root of 3 over 2? It's 2 divided by the square root of 3. So the 2's will cancel out, and you get 1 divided by the square root of 3. Well, you know that's not in simplest radical form because there's a square root in the denominator, so we're going to multiply by a form of 1 that rationalizes that denominator, the square root of 3 over the square root of 3. And 1 times the square root of 3 is the square root of 3. The square root of 3 times the square root of 3 is the square root of 9, which is 3. And remember, you cannot cancel this 3 with this 3 because 1's in the radical and 1 is not. So the tangent of 30 is the square root of 3 divided by 3. That's simplest radical form. All right, let's try another one. What's the tangent of 60? Well, again, just think about what a 60-degree angle has for its sine and cosine. Well, that just means that the sine, in this case, is going to be the square root of 3 over 2. The cosine is going to be 1/2. So it's kind of like the last problem, but flipped. So we're going to rewrite it as a multiplication problem, the square root of 3 over 2 times, then we'll take the reciprocal, 2 over 1. The 2's cancel out, and you get the square root of 3 over 1, which is just the square root of 3. Again, relatively quick and simple to do if you understand the reference angles. Let's try this one. The tangent of pi over 3. Well, that's radians. How are we supposed to figure that out? Well, a couple of lessons ago, we learned how to convert pi or into radians into degrees and vice versa. So let's do that over here. Pi over 3 times, let's see, we put the 180 on top, the pi on the bottom so that they cancel out. 180 divided by 3 is 60. Well, we just did that one. That's the same as this. So that means we don't have to do any more work. We already know the answer. It's the same thing. It's the square root of 3. Now, I did all of this if you would have recognized right away that pi over 3 and 60 degrees are identical, and the more you do these, the easier they get like that. You wouldn't have had to do any work at all. You would have just said, well, it's the same thing. How about this one? The tangent of pi over 6. Okay, I hear you yelling at your computer. Pi over 6, that's the same as 30 degrees. It's the same thing, so the answer is going to be identical. It was the square root of 3 over 3. So radians, degrees, it really doesn't matter. We're still just using the unit circle. All right, the cosine of 90. Well, if you ever get stuck, just draw yourself a little picture. Draw yourself a picture of the unit circle. A 90-degree angle would be this point up here. Well, what are the coordinates of that point? The coordinates of that point are 0, 1 on the unit circle. And you know that the cosine is the x-coordinate of any ordered pair on the unit circle. So the cosine of 90 degrees is 0. You can see why the ACT test loves these kind of problems because, again, you can figure them out very quickly and very easily without your calculator, and you can put the answers in simple radical form. How about this one? The cosine of 0 degrees. Well, let's use our same picture. Here's 0 degrees over here. That's going to have the coordinates 1, 0. So this time the cosine is 1. Very quick, very easy, as long as you understand the special angles. How about the tangent of 0? Well, tangent, we just learned, is opposite over adjacent or sine divided by cosine. So for 0 degrees, the sine is 0, the cosine is 1. So what is 0 divided by 1? It's 0. The tangent of 0 degrees is 0. Okay, you're starting to get this. Tangent of 2 pi. Tangent of 2 pi. Well, let's draw ourselves a circle. You know that 1 pi is 180 degrees, so 2 pi is 360. So that means you're going from here all the way around back to there. Well, on the unit circle, what is that point going to be? It's going to be 1, 0. Sine divided by cosine. 0 divided by 1. So 2 pi, isn't that the same as 0 degrees? That's what we just figured out on the previous problem. 2 pi and 0 degrees have the same cosine and the same sine, so they have the same tangent. That's that easy. How about the tangent of 180 degrees? Well, again, draw yourself a little picture if you're not sure. 180 degrees is over here. Here's a 180 degree angle. What are the coordinates of this point? That would be -1, 0. So what's the sine divided by the cosine? What is 0 divided by -1? 0. So again, you get 0 for an answer. Okay? 0 for an answer. Now, can they get any more difficult? Oh, well, we can try. What's the cosine of 300 degrees? I don't know. Let's draw ourselves a picture. 300 degrees. Well, let's see, there's 90, there's 180, there's 270. 270 plus how many more degrees will give you 300? It'd be another 30 degrees, so it goes right about out to there, right? This is 200, 90, 180, 270, 300, that's like an extra 30 degrees there. So you just have to think to yourself, this is like a 30 degree, what would the coordinates of that point be down there? Well, remember your little reference angle. That's kind of like which one of these angles? It's kind of like this one right here, just moved down. If you want to see it right here, it's just like a 60 degree angle, but it's been reflected around the x-axis down to here, 300 degrees, which is the same as 5 pi over 3. And we know the coordinates are 1/2, -3/2. So if we're trying to find the cosine of 300 degrees is really 1/2. Now, I did that by helping you by using this, but you don't really have to. As long as you can draw yourself a little picture like this, you can say, well, I know that's going to be 1/2, and I know that's going to be -√3/2, so the cosine is going to be 1/2. You do not have to memorize this whole thing. You just have to kind of know this one and then be able to translate it. How about this one? The cosine of 180. Well, again, let's draw ourselves a picture. Cosine of 180. There's 180. Coordinates are -1, 0. The cosine is the x-coordinate, so there it is. It's -1. Draw yourself a little picture. After a while, you don't even have to draw yourself a picture of these. After you practice these enough, you get pretty good at them. How about this one? Last one. Cosine of 7 pi over 6. Yikes. Well, I know that 1 pi is like 180 degrees. So from there to there is like pi. So that would be another 1/6 added on to that. So that would be like another pi over 6. So that would be the angle right there. Well, what are the coordinates of that? The cosine would be -√3/2. The sine would be -1/2. I'm sorry, that's really small. But you know in quadrant 3, both the sine and the cosine are negative. So the cosine of 7 pi over 6 is -√3/2. Okay? It takes a little bit of practice, I know, but make yourself a little cheat sheet like this, okay? And after you make yourself a little cheat sheet like that, go to IXL Y7 and try some. Get that up to 80%. It's not that bad. And once you get the hang of it, you'll see that as long as you understand just a couple of reference angles, the rest of these are relatively easy. And these will make it a lot easier for us to graph these functions in the lessons to come, which is coming up next. So thank you for watching, and I will talk to you tomorrow. Bye.